All right, mutually exclusive events. Those are events that are where it's impossible for them to happen at the same time. Um, for example, you could have a red marble or a green marble. It's impossible to be both red and green at the same time, and I'm not talking about striped. So it's either going to be red or it's going to be green, but there's no way to combine that. It's impossible to occur both red and green at the same time. This is what they're talking about. So one or the other. All right. So if we're trying to find the probability that one or the other will occur, we are going to add them like that. And let's do an example. If one card is randomly selected from a deck of cards, what is the probability of selecting a king or a queen? So again, the probability for a king is 4 out of 52. The probability of a queen is also 4 out of 52. And if I want a king or a queen, I would add those two probabilities together and reduce like that. All right. Now, what happens if both events could potentially occur? So we did, do you remember when we were doing the Venn diagrams and we had our little Venn diagram like here and here? And this portion right here in the middle is were things that were part of both sets. This is kind of what we're talking about. So when we were doing set A or set B, we added all of set A, we added all of set B, but then we had to subtract off this middle because we don't want to count it twice. So we counted it the first time in A, we counted it the second time in B, but we counted it twice, so we have to subtract off. That's what this is basically saying. The probability of set A, the probability of set B, you add those together, but we do have to subtract off the ones that are both set A and set B. Probability of A and B. So let's do an example. Oh, not sure why that, there it goes. In a group of 25 baboons, and I'm going to use a Venn diagram for this just to make it a little bit easier. Okay, maybe easier. Can't draw a Venn diagram. All right, 25 baboons total. So we have 18 that groom, and we have 16 that screech. 10 enjoy doing both. If you guys remember when we were working with sets, the ones that do both, we do those first, right there. So we put those in the middle first. And then 18 enjoy grooming, but that's already counting the 10 that enjoy doing both. So the ones that just groom, that's 8. Just grooming, that would be 8, where all together there would be 18 that groom. And then 16 screech, but we already counted the 10 that enjoy doing both. So there is 10, or 16 minus 10, 6 just screech. Does that make sense? All right. So we want the number that groom or screech, or remember we add them all up, so we need this one, we need this one, and we also need this one. So I need my 8, and there's 25 baboons, and there's the 10 out of 25 baboons, and there is the 6. Okay, so this is one way of doing this. I think this way is a little bit easier. 18, so we have 24 out of 25 that enjoy grooming or screeching. So the probability 24 out of 25. The other way you can do it is using the formula. So we would have 18 that screech, probability 18 out of 25. Oh, sorry, groom, 18 that groom. 16 that probability, 16 that screech. And we double counted the 10. All right. And if you 18 plus 16 is 34, subtract 10 is 24 out of 25. So you get the same answer either way. So whichever way feels more comfortable for you, you can draw a Venn diagram and add it up this way, or you can use the formula where you take the total plus the total minus the ones that do both. So either way, whichever works best for you. All right.